Hello good day viewers. Here is another problem related to derivative. We are given that if x raised to the power of a multiplied by y to the power of b is equal to x plus y raised to the power of a plus b, we are asked to show that dy over dx is exactly equal to y divided by x. Alright, let's get started. We're going to take this function right here and differentiate it, show that it is the same thing as y divided by x. Alright, here is our function. This is an implicit function. Let us take log of both sides. We have log of the left hand side, which is x raised to the power of a multiplied by y raised to the power of b. This is the same thing as log of x plus y raised to the power of a plus b. You know, the left hand side can be split since we have multiplication. This is the same thing as log of x raised to the power of a plus log of y raised to the power of b. This is equal to, we apply one of the laws of logarithm. This power will drop down to multiply. So we have a plus b multiplied by log of x plus y. The same thing to the left hand side, we can apply the law. These powers will drop down. We have a multiplied by log of x plus b multiplied by log of y, and the right hand side will remain the same. A plus b multiplied by log of x plus y. So now we are free to differentiate every single term. If you differentiate this, remember a is constant, so it's like we are only differentiating log x, which is the same thing as 1 divided by x multiplied by a. We have a divided by x plus, if you do the same thing here, you have b divided by what? Y. But remember that y is a dependent variable. You have to multiply by that derivative, that is y prime or dy over dx. It doesn't matter. This is equal to, remember a plus b is constant here, so we are going to differentiate this. If you differentiate that, you're going to obtain 1 divided by x plus y. So it's like saying a plus b, which is going to multiply, right, by 1 divided by x plus y. So we have x plus y here. But don't forget to multiply by the derivative of this. You have to apply chain rule. If you differentiate x, you have 1. You differentiate y, you have y prime. So let us expand the right hand side. We have a divided by x plus, I can write this as b y prime divided by y. This is equal to, you take this, you multiply by 1, it will not change. We have a plus b divided by x plus y. Then you add, you take the same a plus b divided by x plus y, you multiply by y prime. That will give us y prime multiplied by a plus b divided by x plus y. So now let us bring those that contain y prime together. So I can bring this one to the left hand side and take this term to the right hand side. So to the left hand side we have by prime, right? So we have by prime divided by y. As the other term crosses over, it becomes negative a plus b divided by x plus y. You multiply by y prime is the same thing. This is equal to, already we have a plus b divided by x plus y to the right hand side. As this crosses over, it becomes negative a divided by x. So the left hand side, the two terms contain y prime, so we can bring y prime outside. Inside we have what? B divided by y minus a plus b divided by x plus y. And this is equal to a plus b divided by x plus y minus a divided by x. So now let us simplify these two terms separately. Let me start with the left hand side where we have y prime outside. Inside, you take this, you multiply by this. That will give us bx plus by. We have bx plus by. Then you subtract the whole of y multiplied by this. All signs will change. So we have minus ay, then minus by, right? Divide by the product of the denominators. We have x plus y multiplied by y. Then you move to the other side, you do the same thing. We have x multiplied by a plus b. We have ax plus bx, right? Then you subtract a multiplied by this. Every sign will change. Minus ax, then minus ay. Divide by the product of x plus y and x. X plus y multiplied by x. So for cancellation, you can see that by minus by is 0, right? And from the other side, we have ax minus ax, which is 0. So what do we have left? Let me rearrange it. To the left-hand side, we have y prime multiplied by, to the top, we only have what? bx minus ay. Divide by x plus, I can even cancel this one, right? This and this can cancel because they are exactly the same. So here we only have y. So let me write y here. And to the other side, we have bx minus what? ay. Divide by what? X. And also you can see that these two terms can cancel because they're exactly the same. We just have y prime multiplied by 1 divided by y. This is equal to 1 divided by x. We can multiply both sides by y so that this fraction will go. If you multiply the left hand side by y, you're going to be left with y prime, and this is equal to y divided by x. And remember that y prime is the same thing as dy over dx that we are looking for, which is equal to y divided by x, and hence proved. We have shown that dy over dx is exactly equal to y divided by x. But let me give you an additional bonus. Let us show that the second derivative is equal to 0. Because this is the first derivative, right? The second derivative, we are going to take this and differentiate it again. Therefore, d squared y over dx squared. Applying quotient rule, you take the bottom, you multiply by the derivative of the top, right? You subtract, you take the top, you multiply by a derivative of the bottom. The bottom is x. If you differentiate it, you get 1. Divide by the bottom squared. But remember that y prime is first derivative, which we have as y divided by x. So let us bring it back. Therefore, this will be equal to x multiplied by y divided by x, then minus y divided by x squared. If you multiply these two together, you're going to obtain y, and y minus y is equal to 0. So this is equal to 0 divided by x squared, which is equal to 0. Therefore, d squared y divided by dx squared, which is the second derivative, is nothing but 0. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.